So if you were going to ask the question, what's the best diagnostic tool, you'd expect the answer to be in the shape of something like this. However, I believe that the multimeter is the best diagnostic tool, and I'm going to tell you why. And actually now we have got our very own multimeter, and you can get one free when you sign up to the annual Diagnostic coach subscription. So quite a while back I used to help some of my friends out in their garages with problem diagnostic jobs, and I would always carry some sort of diagnostic tool with me, scan tool that is. Now the thing is, whether you're using a tool like this which costs around about £3,500 or a tool like this which costs £10, there's no doubt in my mind that the very next tool you're going to have to pick up is something like that. So if you understand what the diagnostic tool is telling you, so fault codes, live data, you're then going to have to follow that up with some sort of measurement. That's your first port of call. Let's take a look at the different types of meters you can get and what you should look for when you're buying your own. After that, I'm going to show you some of the really cool features that you might not be using already. Okay, so we've got a selection of multimeters here, and this is the kind of decision that you might be faced with when going to buy one. Now, they all do pretty much the same basic features. However, there's some things that you should look out for when buying one for automotive diagnostics. So let's start at the cheap end of the spectrum. Here is literally the cheapest multimeter that I could find on Amazon, and it was bought for around about £6 British. Now they work, they do the job. There's lots of people that use these. However, one of the downsides of a multimeter like this is you have to know what range you're selecting. Now, some people like the idea of manually selecting a range. However, it can be quite confusing if you don't know what you're actually testing in the first place. And the other thing with these types of multimeters is they can end up lacking some of the other features that are quite useful, like frequency and duty cycle measurement. However, they do the job. You've then got something then at the other end of the spectrum. So this is an automotive multimeter from the ProLogix guys. Now this multimeter has some very basic features on the front there. However, once you go in there, you can select alternator test, starter motor test, other specific tests where this has built-in diagnostics for you. Now, it's great and it does the job. However, it could be a little bit overkill if you just want to get it out and, check the battery voltage. You might have to press a few buttons before you can get to a basic voltage measurement. Then we've got like the premium range. Most of you might have heard of a Fluke meter before. Now that's the brand that's widely known as producing the best multimeters in the business, whether it's automotive or any other electrical measuring trade. However, this one here, although it is a Fluke meter, it does lack some of those useful features like a millivolt setting. Okay, so a millivolt setting can be really good for certain battery drain testing and even voltage drop measurements and things like that. Doesn't have it. It's a Fluke meter, but it's not the best multimeter in my toolbox. We've then got this one here, which is from Mac Tools. Now, I bought this one after I'd been in the trade for a couple of years. It cost me around about £250 back then, which was quite a lot of money for me at the time. Quite annoyingly, actually, a few months after I bought this, BMW gifted me this one for passing my senior technician exam. So I ended up with two fairly decent multimeters. Now this is classed as an automotive multimeter. Similar to oscilloscopes, the automotive multimeter has a few more features that might be a bit more useful when working on automotive diagnostics. The features on this though are probably a little bit outdated. So we've got RPM via the ignition cable, which most cars don't have ignition leads anymore. It also work out the dwell angle. Some things on there that probably aren't really that useful anymore. So a really good rounded multimeter like the Mechanic Mindset multimeter has all of the good features that you need and is actually quite good value as well. So on here we've got the voltage measurements, we've got millivolts. It will do duty cycle and frequency measurements. It actually also has a temperature sensor So you can do things like air conditioning, HVAC diagnostics as well. So it's really quite useful. So the other ones that we've got on the end here aren't strictly classed as multimeters. One of them is a milliohm meter. Although it does also have a voltage measurement on there, you wouldn't typically buy this for measuring voltage. It also has these weird Kelvin measurement probes on there. So this tool here is actually designed for measuring very, very low resistances. So things like the windings in a three-phase electric motor, even a piece of wire. So you could connect this up to a piece of wire, cut the strands and see the resistance change, which is why we don't use a multimeter like this for measuring the resistance of a wire. I'll demonstrate that in a moment. So that's the milliohm meter. And then we've got this here, which is commonly known as an insulation tester. This is for measuring mega ohms, so very, very high resistances, which is what we require in the insulation of high voltage circuits. So this can measure very high resistances under a higher voltage load. So we can actually set this up to 1000 volts and it will put 1000 volts out down the leads and make sure that the insulation is within the specific resistance measurement. So slightly different multimeters for two different purposes, but again, they do come under that multimeter bracket. However, this is like your all-rounder, okay? It's the one that you're going to be picking up most of the time. So let's take a look at some of the features that we've got on here and how you can make the most out of your multimeter when performing automotive diagnostics. So before we get started, we're going to want to plug our leads into the multimeter. Now, most multimeters ship with leads like this, and I absolutely hate them. So the problem with these types of leads is that the temptation is always there to try and stab that end there, that sharp end, into the wire, because you can't get it into the back of the connector. It's not small enough. And you know, if you're doing diagnostics out there, I guarantee that you've seen that. You know, you go to the wiring, you can see where the previous mechanic has stabbed those into that wire, and it's either caused another fault or it's a car that's already been looked at somewhere else and they've just stabbed around the wires and left it like that. So over time, that's going to be a problem. That's going to cause corrosion and more faults and more costs for your customers. That is why the Mechanic Mindset multimeter ships with leads like this. We specifically asked for some high quality leads with banana connectors, so the 4mm connectors. You can still use those if you want. They're okay for like measuring the battery voltage and other, you know, clunky stuff like that. However, if you want to do diagnostics, measuring voltage drop and sensor power supplies and things, what you're going to want to do is attach some back probes, okay, and maybe a crocodile clip like that, so that you can connect that onto a good chassis ground and then use that to then back probe into the connector very carefully, so that you can test the system all connected up and you know you're not going to damage it. The other temptation with the other type of lead is that we disconnect the connector and then, you know, measure the voltage here at the front, you know, either damaging the connector down the front there, or, you know, going at the side. Now, that's fine, you know, if you can get on it, but that causes another issue where we've now opened the circuit and we're not measuring the loaded voltage drop. So the banana leads or the 4mm leads are what you really want for diagnostics, and then you can connect all your different accessories up and make sure we don't damage anything on the vehicle while we're testing it out. So the first setting that we're going to take a look at is the AC voltage. So it's this one here with the little squiggle next to it, okay? And the little squiggle there, that represents AC voltage. So voltage going above and below 0 volts. Okay, so it's alternating current, alternating voltage. Now, there's not many things on the vehicle where we would use this alternating voltage measurement. we do have it still, very much so. It's inside the alternator, but that gets rectified back out to DC for supplying the vehicle with a power supply and charging the battery. However, some rotational sensors like crankshaft sensors and wheel speed sensors still generate their own voltage like this. And on those types of sensors, you can actually use the voltmeter to check that signal output. We've got an example right here where we are checking the crankshaft sensor on this Audi A4 2-litre TFSI. And what happens then is the faster it gets, if you looked on an oscilloscope, you would get more of these alternating signals on the screen, and they would also get higher. When they get higher, that means that you would be able to measure that with this AC voltage setting on your voltmeter. So we cover all of those sensor diagnostics lessons in the Mechanic Mindset Diagnostic Coach, which can also be accessed via the app. So make sure you go and check that out. What we're going to take a look at then is something called alternator ripple. Now, you might have seen that before on your battery tester. It usually brings it out on the report. It says ripple, so many millivolts. I'm going to explain what it is, and what we're going to do is use this voltmeter on the AC setting to test the alternator ripple on this vehicle here. Now, you might have seen alternator ripple on the battery test that you might have done before. If you've got one of those handheld battery testers, they usually give you an alternator ripple measurement, and it will be like a low number in the millivolts range. We're going to do that test with this here today. I'm going to explain what that ripple is first though. So alternators actually have 3 of these phases inside them. So what you can imagine is that we've got one single phase going along here. We've got another one running alongside it, and another one running another 120 degrees out from that one. So what the rectifier does is basically flips all of that upside down, so we only get positive pushes. What that results in is a ripple where we only see the tops of all of these phases put together. And that's what your battery test is putting out there. Now, if one of those rectifiers inside there uses diodes, fails, what we end up with is a bigger drop on that ripple, okay? And that can be picked up then using the AC setting. Let's take a look at what the ripple is on this car. And ideally, we want to get onto the power supply of that alternator if we can. But we're now just measuring everything across the alternator rather than the whole system. So we've got the ground onto the body there, and then the power supply going on the back. And if we just put it onto the DC setting, we can see we've got battery voltage there. So we know we're connected. What we can do is just make sure that the alternator is charging. So we're going to start the engine and just put some loads on, like the heated rear screen. And we can see there that we've got about 13.5 volts. Okay, so we are getting some charge there from the alternator. And if we just go over to that setting there for the AC voltage, you can see there that we're getting around about 60 millivolts AC. Now, you don't really want to see that reading going much more over 100 millivolts. However, I have tested vehicles with no faults before, and this can go up to around 200. Basically, just a really nice quick check to see if that rectifier is doing as it should. Of course, if this is like 1 volt AC, then you've got a problem for sure. What you might want to do next to just confirm that is check it with an oscilloscope. And I've set the oscilloscope up here, and you can actually see that ripple. Again, we're just measuring the battery voltage directly, and adjusted some settings on the oscilloscope to see this, but that's essentially that AC ripple there. So the AC voltage setting still has its place in modern automotive vehicle diagnostics. Next, we're looking at the most common thing you're probably going to use on the multimeter, and that's the DC voltage setting right there. So first of all, we're going to take a look at battery voltage measurements and then some of the other testing that you might do with this setting. So a quick battery voltage test is going to tell you really the condition of the battery, and it's going to save you time when trying to diagnose different problems, like when you've got control units not talking or the vehicle's not starting or other random kind of faults that sometimes overlooked from a basic check. So it's really quite simple. 12 volts doesn't mean that the battery is 100% charged. As we know, we've got a 12 volt battery on our vehicles. Actually, 12.7 volts represents a 100% charged battery. Take it down to 12.4, we're then looking at around about 60% charge. 12 volts, if you measure 12 exactly, is 25% charged. So that battery would really benefit from being topped up by a battery charger or whatever. Now, when you start getting down to 10.5 volts, that's the 0% mark. So 0 volts isn't 0%. Remember, this is a 12 volt battery and it's supplying components that work off 12 volts. Once you start going below 10 volts, these components aren't going to work at all. Okay, so we tend to see that with control units on weak batteries when you're cranking the engine. If that battery voltage starts dropping below 9 volts, the control units don't work anymore because they need 12 volts to operate. So a quick look at this battery that's been sat at the back of the workshop for a couple of years now. Let's see how this fares up state of charge. So you can see there that we've got 12.37 volts, which is around about 60% charged. Now, the other thing you need to consider is state of charge doesn't mean that the battery's okay. We've also got another metric called state of health. What we would usually do is put this battery under some load and see what the voltage drops down to while we crank the engine over. So let's go ahead and do a state of charge and state of health check on the Audi here. All right, so we're going to connect up to this chassis ground point here, and there's a jump post just behind there for the positive, and you can see that we've currently got 12.48 volts, so probably around about 70% charge in the battery. The other thing to mention is with the state of charge, you need to remove the service charge after you've charged the battery. So as soon as you charge the battery, you might see 13 volts on there. You just need to maybe put some load on it just to remove that excess charge that is giving you that higher reading. So what we're going to do now is crank this engine over and see what this goes down to give us an indication of the health of the battery. We're going to use the min-max feature on this Mechanic Mindset multimeter to see what we get when we crank the engine over. Okay, so we can see that the minimum voltage is around 10.4 volts. A good reading would be around 10 volts. Anything going down then towards 9.5, 9 volts, you've got a battery which is not in great shape. So there's some quick tests there using the DC voltage function for assessing the condition of your battery without relying on the battery tester. Now we can understand what the battery tester is actually looking at. Now we're going to go down the route of having a look at the voltage drop testing, which is something that's very important for automotive diagnostics. So when performing your voltage checks, there's a few things that you need to be aware of on how the voltmeter works and how the actual circuit works. So we've got a simple light bulb in a circuit here with a power supply of 6 volts. This is the ground side, this is the positive side. And if we check the battery voltage there, you can see that we've got around about 6 volts on the display. Okay, so if we were going to go ahead and check the power supply to the bulb, we would want to turn the bulb on and check it there, and you can now see that we've got 5.4 volts. So what you need to remember is that we haven't lost 0.6 of a volt in this line. Remember the power supply was 6 volts. What's happened is the battery voltage has dropped ever so slightly since we've put it under load. So similar to that load test we just did on the battery. So how your voltmeter actually works is it measures the difference between 2 points. So when we're measuring the battery voltage here, we're measuring 0 volts on this lead and 6.7 volts on this lead. So that gives us the difference of the positive and negative. Now you can actually use that in the same way, just measuring along the piece of wire. So how much voltage has that piece of wire lost? So what we're going to do is put one of the leads on the actual power supply here, switch the circuit on, and the other one here. And you can see there, look, that has lost 0.2 of a volt along that wire. Now that's a voltage drop test, and they're very important tests for accurate diagnostics. Many incorrect diagnostics from people not doing this simple check. Let me show you how. So what often happens in diagnostics is because of the access on the vehicle, we usually take the connector off and then measure the power supply voltage going up to the consumer. So in this case here, we might measure the voltage all the way up there, and you can see there that we've got 6.76 volts, which is actually exactly the same as we got down here. Now what you'll notice now, with it switched on like this, there's no drop along the wire, there's no voltage drop. Now that's because there's no current flowing down it. So if we actually use our multimeter and check the difference of both ends like we did a moment ago, we will see that we get exactly 0, so 0.000, because there's no difference in voltage along that wire. Okay, now remember, when we connected it up and turned it on, there was a difference, a small difference, but there was a difference. Now where this method of diagnostics comes into being a problem is when we've got a fault in the circuit. So I'm going to put this resistor in here now, and what you'll notice is when we turn it on, the light doesn't come on at all. Okay, so if you go ahead and then disconnect that like you would on the car, then measure the voltage at the connector, it all looks okay, right? So we've got 6 volts on the end of that cable. Okay, however, when you connect it up, this circuit is now operational. Measure the voltage at that bulb and we've got hardly anything there. It's all been used up by this resistor. So if you go along this supply here, you can see we've got 6 volts before the resistor and nothing after it. Okay, but remember, you're only going to see that if you leave the circuit connected. You know, let's just show that again. Look, so if I now disconnect this, we've got 6 volts on the end of here, and that's because there's no load on this anymore. Okay, there's no current flowing through it. That there is not using any of that voltage. So we can demonstrate that in a slightly better way with a lower resistor. So this resistor value here is around about 7 ohms. Okay, so if we again check the voltage on the end of there, we can see we've got 6 volts. If we now connect it up, we can see the bulb is on, but it's dimmer than it was before. So if we check that voltage now, we can see that we're only getting 4.2 volts going to that. So that must mean that this resistor is using around about 2 volts. Okay, so if we do the voltage drop test across there, measure the difference, yeah, we can see 1.5 volts. So I was a little bit off there because we've turned that on and the battery voltage is loaded now. There's the voltage drop testing and a good indication of why you shouldn't disconnect components when you test them. And another reason why we supply banana cables with our multimeter, so you can attach a back probe and test the component without disconnecting it, so we can just test into that wire in the back of that connector. Something that we're going to explore a little bit later on is why we don't use the bleep test, or I say the bleep test, the continuity test on the multimeter. And what I want to just show here is that actually with this resistor in there, we still get continuity through that multimeter. So that's one thing you need to be very careful of when using that continuity tester. It's only really any good for complete open circuits where you're definitely not going to get any continuity. So this is what also makes the voltmeter so good for ground testing. How often do you look for 0 volts and say that's a good reading? Let me show you. So we've got the black lead connected onto the ground there, okay, so that black lead is on 0 volts, and we've now moved the switch onto the ground side of the circuit. So what we should expect to see is that we've got our 6 volt power supply. Again, you can apply this to a 12 volt circuit on a car as well. We've got 6 volts up to this light bulb here because it's uninterrupted, and then on the other side, look, we've also got 6 volts. Okay, so this is the ground side now, and we've got 6 volts. But because it's not turned on, that's not ground yet. So that's not a good reading if you know, we were to have the switch on. However, if we turn the switch on now, you can see that we go down to just under 0.2 volts there, okay? So that is a good reading for a ground. And it's a really good way of testing high current circuits like starter motors, you know, that ground strap that's in between the engine and the chassis. Really quick test, I'm going to show you that one moment. So if we just put that high resistance in there again, if we check the ground now, we can see that it's not 0 volts. Look, it's much higher. Now the general rule of thumb for ground testing is I usually say half a volt, so 0.5 volts. Some manufacturers will say 0.3, others will say it really depends on the circuit, and it really does. So it all really comes down to Ohm's law, how much current is being pulled through that circuit and how thick are the wires. Basically the current flow and the wire thickness is what determines how much is used on that circuit there. Okay, so let's set up this ground test on this starter motor here. Before we get going, I have disconnected the injector wiring loom down here, so this engine's not going to start. And all we're going to do is put the black lead on the chassis. Ideally, you want to go on the battery ground, the battery negative. It's in the boot on this car at the back, so we're just going to go here. We're just testing the bit in between. And then you just want to put the other lead anywhere on that engine, okay? So now we're measuring the difference in voltage between the engine and the chassis. And of course, we said that should be as close to 0.5 of a volt as possible. So what you can see now, because there's no current flow at all, we've got 0.000, okay? That tells me at least it's connected, okay? Because if we take one of these leads off, that figure starts flickering around a bit. You see how it's flickering? If you put it on there, it will stay flat zeros if it's connected to 2 ends of a piece of wire. So what we'll do now then is we'll crank this engine over and we'll see what reading we get. Okay, so here we go. Let's keep an eye on that figure while the engine's cranking. And we've got 0.06, which is a great reading. Okay. Now, if that ground cable between the engine and the chassis was all corroded, or the connection was all green and crusty, that would be equivalent of what we tested here, and we would expect that reading to be much higher. That would give us the go-ahead to go and actually investigate that ground. Such a quick test. So many batteries and starter motors have been replaced unnecessarily because this test wasn't conducted before they went ahead and replaced parts. So really quick. It also applies to the live side as well, so you can just do that exact same test, live side of the starter motor, live side of the battery. So now we've looked at the standard DC voltage setting, and we should be happy with the concept of voltage drop, which is going to help us make the most of this next setting, which is for measuring millivolts. Okay, so now we're taking the voltage measurement down to a much smaller value. So in the normal DC voltage range, we can only measure down to 3 decimal places. So that there is 1 millivolt, okay? 1 millivolt. Now for this next test I'm going to show you, you're going to need to be able to read down to millivolts to at least 1 decimal place. So 1/10 of a millivolt. That's a very small measurement. Now the Mechanic Mindset multimeter actually goes down to 2 decimal places, so really quite an accurate bit of kit. Remember, you can get one free if you sign up for the annual subscription. So let's take a look. I'm going to show you the measurement we're going to do first, and then I'm going to show you the voltage drop chart we're going to use to work out how this can be useful. So we're in the engine bay of this old 3 Series now, and we're going to take some measurements on the fuse box down there. And what we're going to do is something called fuse voltage drop. And this is a really useful test when you're doing battery drain diagnostics. So as you know now, on modern cars, if you take a fuse out, which you might do to find out where a battery drain is coming from, it can wake the car up, and then you have to wait another hour for the car to go back to sleep and you can resume diagnostics. Now the fuse voltage drop test means you can identify where a drain is simply by checking the voltage drop across the fuse, okay? So what we're going to do is use 2 back probes like that, measure the voltage drop across it, and remember from the last session, if there's no current flowing, there is no voltage drop, 0.000. So this car should be asleep right now. The ignition has been off for quite a long time. If we just go across some of these fuses, we should see that the voltage drop across them is flat 0. Can you see that now? 0, 0.00. Okay, can test another one there. Again, all zeros. This means there's no current flow going through these fuses. Okay, so that one got a tiny bit of current going. No, 0. Get the idea. What I'm going to do now is switch the ignition on and have a look at what we get then. So the ignition's on, and hopefully there's current going through some of these fuses now, and we can see what we get. So I'm going to go across this brown 7.5 amp fuse here, and now we can see that we've got 0.41 millivolts, okay? Before it was reading absolute flat zeros, okay? So now there's current flow through this circuit. We've got a very small voltage drop. So let's go over to the chart and see what that means. So if we have a look on here, we're on the standard ATO fuses. You can download this voltage drop chart. Go over to mechanicmindset.com and get yourself a copy. We were on a brown 7.5 amp and we got 0.4 millivolts on the drop, okay, across the fuse. So that translates to 37 milliamps. So if you were doing a battery drain test, you'd be able to work out whether that fuse was a problem or not. General kind of rule of thumb for battery drain diagnostics was 50 milliamps for us. Of course it could be more and still be okay. It's a bit more complicated than that. We have got a whole course on battery drain diagnostics in Mechanic Mindset Diagnostic Coach. We cover all the ins and outs of doing that diagnostic test. However, 37 milliamps that we measured there might not be a problem, okay? So what you would then know is to carry on looking for your drain over the fuses, and it just means you haven't got to keep pulling fuses out to find something. So if we check out one of these 10 amp fuses here we've got 6 millivolts over this red 10 amp fuse. So here's the red 10 amps. If we go down to 6 millivolts, you can see that that is a significantly higher amount of current. We're on to the next page, and 6 millivolts is here, red 10 amp fuse, 779 milliamps, which roughly converts to 0.7 of an amp, nearly 0.8 of an amp. So 800 milliamps, 700 milliamps is way too high for a parasitic drain while the car's asleep. So what you would want to do then is find out what that fuse was, what it supplied, and if any of those are still awake or faulty or have an internal short circuit in there, something that's pulling the current through when it shouldn't be. So that's a really nice test. So on to the next setting on the multimeter, and we're going to have a look at the resistance and continuity setting. We've already touched on that a little bit in the previous demonstrations, but let's go and have a look at what else we can do with that. So the resistance setting on the multimeter, measuring ohms, that's that little symbol there, the omega symbol, is really good for checking the condition of different components. Now, if you remember at the beginning of the video, we talked about the other testers that you could possibly use for resistance checking. That was the milliohm meter for measuring really small resistances, and then the mega ohm or insulation tester, which was for measuring really high insulation resistances. A multimeter like this is just perfect for measuring those things in the middle. It's not very accurate at very low resistances, so when you start looking at diesel common rail injectors, they are actually quite a low resistance, and this isn't so accurate for that. You would probably need a milliohm meter to get the most accurate measurement. However, for things like this, it's absolutely perfect. So let's take a look at what we've got. So here we've got a selection of components. There's a glow plug here. Now, what you need to remember when you're testing the resistance of components, it needs to be removed from the circuit. Okay, you have to disconnect it from the control unit, from the battery, whatever. That just makes sure that you get an accurate reading. Ideally as well, you don't want to be touching the two probes, because as you can see there, if I touch these probes, although it's a very, very high resistance and isn't going to make much difference to the resistance of this glow plug, it could affect what you're measuring, especially if you were measuring something like this, which has a slightly higher resistance. So yeah, ideally you don't want to be touching the two probes. I'm touching the one there, and then if we just put that on there on this side, we can see that we've got a very low resistance, around about 1.5, 1.3 ohms. Okay, so the glow plug there, what will happen is as this gets hot, the resistance will increase. So if you have just taken these out of the engine to measure the resistance there, expect to see a much higher reading than that, you know, possibly up to 4, 5, 6 ohms, maybe more, okay, depending on how hot that glow plug is. But when they're cold, around about 1 ohm is normal. We've then got a H7 headlamp bulb there, so I've just got it in the case. Let's have a look at what we've got on this. Again, the resistance value is going to be relative to how much power it consumes. So here we've got just 0.5 ohm, okay? And again, the same thing with that. As it gets hotter, the resistance will increase. So if you've just taken it out of the vehicle, it might be slightly different value. But again, these two here are going to be drawing a similar amount of power. This one probably a little bit more. But, you know, again, these get really hot as well. So, you know, they're in the same kind of ballpark. If we then go on to test this injector, this is just a normal injector. I'm going to use some of these little breakout leads here. They're really useful for testing components like this, rather than having to struggle to actually hold the probes on there. As we've got our 4mm banana connectors with this multimeter, it makes it really useful. So if we connect onto that injector there, we can see that we've got around about 12 ohms on there. Okay, so again, what you'd want to be doing with this is comparing that with the other 4 injectors on the vehicle if you suspected a problem with it. But it is a nice quick test just to see whether there are any short circuits or high resistances in that injector, or an open circuit. What we've got here then is a coolant temperature sensor. These are still widely used on all vehicles really, and not only on the engine, they are fitted to different parts of the vehicle as well, like ambient temperature and the heating and air conditioning system. We can see there, look, that we've got around 2.4 kilo ohms, so 2,400 ohms. That's a very high resistance. So this doesn't draw much current at all because of that high resistance. Again, it is just a sensor. It's not actually doing anything. If we then kind of hold that, we should see that this resistance starts to change as we warm it up. So you can see there that resistance dropping as it gets warmer. So that's actually the opposite of what happens with the glow plug and the headlamp bulb. The resistance increases when they get hotter. This is it's what's known as negative temperature coefficient. Probably a word you don't say very often, but it just means that the resistance drops as it gets warmer. Okay, so a nice quick test there on the coolant temperature sensor as well. So earlier on in the video, we looked at using the resistance setting for checking the piece of wire and noticed that there were some possible flaws in that. Of course, you can check the resistance of a piece of wire, and we should be expecting around 0 ohms really. There should be very little resistance in a piece of wire. So you can see there we're getting down to about half an ohm there, 0.4 of an ohm. However, look, so that is actually just holding on there by one strand, okay? Actually connecting those up doesn't really make any difference to that resistance reading, which is why the resistance setting isn't very good for measuring pieces of wire. You would need a milliohm meter plus lots of other information. So the continuity test gets used quite often, also known as like the bleep test. So as long as you've got continuity, it will bleep. So as you can see here with this wire that's, you know, broken, it's still going to bleep. But something that you might not know about that continuity tester is it will still bleep with quite a high resistance. So this is called a decade box, and it ramps up different resistances at different levels. So we've got 0.1 of an ohm, 1 ohm. So if I turn that now, that's now 1 ohm, 2 ohms, 3 ohms. And then we've got times 10, so that would be 10 ohm increments, 100, 1000 increments. So what we're going to do is connect it up. It's all set to 0 at the minute, so it's essentially a piece of wire going through there, so it should be 0 ohms. And if we just ramp up some resistance, we'll see what happens on the continuity test. So let's just put it on there. So you can see we've got continuity, half an ohm. If we ramp this up, it is going to start measuring that resistance there. But can you see that it's still bleeping? Okay, hopefully it's not annoying you too much at the minute. But I'm going to wind that right round to 9 ohms there, and you can see that it's still beeping. Okay, so it's quite a significant amount of resistance that you're going to need to stop that from beeping. So what we'll do is we'll increase it on the times 10. So we're going to go up by 10 ohm increments this time and see when it stops beeping. So 10 ohms, 20 ohms, 30, it's 40, 50 ohms, okay? So you can see there at 50 ohms is where the continuity tester actually stops beeping. So you've got to be very careful when using that for testing pieces of wire, especially if you're not looking at the display on the multimeter. You could end up measuring quite a high resistance wire, but it's just not picking it up. So one to be aware of, continuity testing, nice for making sure that the wire is complete, but it's not good for checking the condition of the wire. Voltage drop, which we looked at earlier, is what you want to use for that. So the next setting we're going to explore on the multimeter is the Hertz frequency setting. Okay, so this is measuring frequency and it's measured in Hertz. Now, frequency is a measure of electrical signals, and 1 Hertz means it does 1 cycle in 1 second. So it was on and then it was off in 1 second. If it then does on and off 10 times in a second, that makes it 10 Hertz. Okay, so this is quite good for measuring things like that. Now you might be wondering, well, where on the car can you use something like that? So you can actually use it for pretty much any vehicle signal that switches on and off and changes when you alter the vehicle in a dynamic way. So for example, you could do it on a wheel speed sensor signal, and as you get faster, the frequency increases. A crankshaft sensor signal works in a very similar way. However, what we're going to look at is the air mass meter. Most modern air mass meters now use a frequency modulation to send the air mass data to the engine ECU. So let's take a look at what that signal looks like and then how we can use the multimeter to measure it. Okay, so what I've done is gone into the signal wire on the air mass meter, and we're actually measuring the frequency with just the ignition on. So that's the square frequency signal that we get from this air mass meter, and you can see that it's switching on and off around about 5 volts. So we've got 0 volts just there, and it's going on and off at 5 volts. Now the time base on this at the minute is very, very fast. There's 2 milliseconds for every division on this screen, so that's 2/1000ths of a second. So we've only got 10/1000ths of a second on that display there. So very, very fast switching. And if you were just going to use the voltmeter on that, what you would end up seeing is an average of that voltage there, okay? So this multimeter isn't fast enough to switch at 2/1000ths of a second. And even if it could, your eyes wouldn't be able to see that display change. It would just look like a blur. So that's kind of the best tool for checking it in depth. However, I've set up the frequency measurement on there as well. You can see it's at 1.08 kilohertz. This is a little tip here. What you want to do is just make sure that you set it to Hertz before you connect it up, okay? And actually you only need the red lead. We can see that the reading that we've got there, 1081, is exactly the same as the reading that we've got on the oscilloscope there, okay? So 1.08 kilohertz, okay? So now what I'm going to do is rev the engine up, change that air mass signal so you can see what happens. So it's 1 kilohertz with the ignition switched on, so we do get a signal. Now let's start the engine. And we can see there now that that display, the image has got much closer together, much more cycles on the screen, and we can see there that we've gone up to 3.8, 3.7 kilohertz. And if we rev the engine, it's nearly 4,000 revs, we've got 4.8 kilohertz, okay? So a nice quick way just to check that you've got an air mass signal on these digital frequency modulated air mass meters. We've got courses and lots of lessons inside the Diagnostic Coach subscription which show you how to diagnose things like air mass meters, petrol engine management, ignition, injection. We've got lots and lots built up in there to help you get going, even using things like the picoscope oscilloscope for finding those really challenging faults. Okay, so we're moving our way around the dial. The next one we're going to take a look at is the amps measurement. So this is the ammeter setting. One thing you need to remember with the ammeter is that you need to change the lead, okay? So what we've got is two options here. We've got the 10 amp setting, okay, which is what we use for most battery drain problems and things like that. Then we've got the milliamp and microamp setting, which is actually on a separate fuse there. That's not something that you would use as often, really. I've not really found myself using the milliamp feature much before. We use it sometimes in training just to demonstrate the operation of things and current flow and resistance and all that kind of stuff. But the 10 amp setting is the one that you're going to be using the most. Now, you'll see there that it says 10 amp fused, okay, so 10 amps maximum. These multimeters have fuses in, and when you actually switch that over to that setting there, you are now basically a piece of wire, okay? So in the voltmeter setting, we have a lot of resistance on the meter, okay? So it's a very, very safe method of testing. When we put it onto the amp setting, the meter is now basically a piece of wire with a 10 amp fuse in. So quite often when I was in the workshop doing these kind of tests, you do your battery drain test, you know, wrap up your multimeter, put it in the box. The next time you get your multimeter out, you go to connect it over the battery to measure the voltage, and pop, the fuse just blows instantly because you forgot to change the leads around. Now there is a very quick method for checking whether that fuse in your multimeter is okay. And what you basically do is set it to either resistance or the continuity setting that we had before, and put that red lead across back into itself. And you can see there that now it's bleeping. That means that the fuse is okay. Okay. Now if you actually have a look at the circuit on there and why that does that, the fused side actually connects to the ground on the other side of it, okay? So it's almost like just connecting these two leads together. As long as that fuse is okay there, we can actually just check the fuse with a simple test like that. So nice little tip there. Unfortunately, I've been in the trade many years before I found that out. So what I used to do was get 2 multimeters and check it that way. Not embarrassed to say that at all. So what we're going to do then is go over to this car now. The car's already asleep, so I'm going to show you a nice little tip to actually start your measurement without disconnecting the battery and waking the car up and waiting all that time to get the car asleep again. So we've got our car here, and what we would usually want to do is put the ammeter in line with the battery ground. So what we used to do was disconnect the battery ground, put one of your leads on one side and the other lead on the battery clamp. So if we do that now, when we connect it back up again, it's going to wake the car up, okay, which we don't really want to do. This old car here doesn't take long to go to sleep, but some of the latest vehicles, you could be waiting for quite a long time, and we don't want to do that. So work smarter, not harder. Let's put this ground here onto the battery negative. We're then going to put the other lead onto a good chassis ground. Now this one probably isn't the best place to go because it's just quite easy to knock it off, but we're going to put it onto that turret shock top mount there. Just make sure you've got a good connection, and instead of disconnecting the battery here, what I'm going to do is disconnect the actual earth point down on the chassis. So if you see that negative battery cable goes down there, I'm going to disconnect it here, okay? Be careful not to drop that nut. Okay, and then when we disconnect it, we should see then that, in fact, if you look there, look, no current flow going through that multimeter at the minute. When we take this off, there you go. We're now doing a battery drain measurement, and we didn't have to disconnect the battery, wake the car up, or lose the clock settings or the tyre pressure monitoring, a steering angle sensor or anything like that. We're all ready to go. So this is a good reading, really, that 0.037. So that is, again, split into thousandths, milliamps. So 1 amp is 1,000 milliamps. We're at 36 milliamps right now. So that is a really good reading, okay? If it was going above 50, you know, up to 80, then that would start to be a problem. It really does depend on the customer's complaint. How long does it take to go flat, and what size is the battery, okay? From that, you can kind of work out what kind of battery drain you're going to expect to see. So this is still my preferred method over the oscilloscope and over handheld amp clamps, which can be not very accurate at low readings. This, you know what you're getting, okay? There's no denying that reading. Of course, if you had a high reading on here, you could then go ahead and start doing your fuse voltage drop method to try and find out where that drain was coming from. So if we just open that door there, we should see that that goes up, and you can see now that it's drawing at 700 milliamps. So not actually too much, but it gives you a good idea of what we're looking at there. So another nice way to use this ammeter feature is for measuring things like fuel pump current. Sometimes the fuel pump can be really difficult to get to. In some cases you have to drop fuel tank down and things like that. What you could actually do is remove the fuse and then go across the fuse with the ammeter to see if there's any current flow going through that circuit. At least then you know whether that circuit is okay or not. So a nice little feature on there for the ammeter. Don't forget to switch your leads back. So the next setting that we're going to look at on the multimeter then is the temperature setting down here. Now, when you get the Mechanic Mindset multimeter, it comes with this temperature sensor or thermocouple, and it basically connects into the voltage connectors, so the same connections that you connect up a voltage, and then it's got this little kind of measurement tip on the end there, okay? Now, something pretty cool about our meter is that when you put it into that temperature mode, it's actually got its own internal temperature sensor inside. So you can see there, British summertime at its best, 22 degrees Celsius. You can actually change it to Fahrenheit by just pressing that orange button there. So I know some people in the world still like using that Fahrenheit setting. So I like Celsius, and what I'm going to show you in a minute, we're going to use Celsius as a reference. Let me just demonstrate now when we're connecting the little sensor on there. We can now see an increase in temperature when I hold on to the end of that there. It's going up to 30 degrees there, and if we disconnect it, back down to room temperature. So really nice feature there. So where can you use this? Heating and air conditioning is a really good feature, especially for air conditioning performance tests, just to quickly get an idea of how the system's working. Let me show you what you can do. So air conditioning basically reduces the temperature of the air coming into the cabin. What it does is removes the heat from that air using the evaporator just behind the dash. Of course, when it's working properly, it should reduce that temperature of the air by a set amount. Now, what we used to use as a base measurement was 15 degrees. So the air conditioning system should be able to reduce the air temperature by 15 degrees outside ambient. So we already saw that we were around 22, 23 degrees in here. So what I'm going to do is start up the engine, get the air conditioning set on maximum, and we're going to take measurements across the dash, okay? What we should see is we get roughly the same temperature across the dash. If it's less on one side than the other and gets warmer, that generally means that you're low on refrigerant and most of the cooling is done on one side of the evaporator because we've got less capacity in there. So we'll start up the engine. We've gone to max low, air conditioning is switched on. Okay, that's already coming out really quite cold. We'll just give it a moment. Go down this one here. And we can already see that value coming down there. And we've got it down to about 14 degrees Celsius. So what's that, a drop of around 9 degrees, okay? So if we now go into the center vents, we can see that that's dropping much further. We're already down at around about 8 degrees there. So closer to our 15 degrees drop. Let's go into the vent next to that one. Slightly less again, that's gone down to, just flicked over to 7 degrees there. Gone back up to 8, whereas the other one was floating between 9 and 8. Let's go over to this one at the far end. And we've got similar to the other end there, around about 11 degrees. So although this air conditioning system is working, it would probably benefit from a recharge. But that's a nice quick test that you could do, maybe even as part of a service, just to let the customer know how their air conditioning is working. Really quick, really simple, really effective. So I hope you've enjoyed that video there, and it's going to help you get more out of your multimeter and automotive diagnostics. As I mentioned, you can get one of these free right now. Global shipping is included when you sign up to the annual Diagnostic Coach subscription. Inside there we have lots of diagnostic courses on different topics like electrics, sensors, engines, and that's petrol, gasoline and diesel. We also have some electric vehicle training, canvas and networks, and I think we also added a course on ECU cloning just recently. Every month we hold a live training session which you can join, and if you can't make it, then we do record the session for you to watch afterwards. Throughout the months we tend to try and switch up the time zones so that everyone can join in, but Sunday 7 PM UK time seems to be a favourite for most people around the world. Then there's the Private Mechanic Mindset community, where you can get technical support from me and all the other members from around the world. Either ask the questions on the problems you're having, or share some of the wins that you've had with diagnostics from your newly learnt diagnostic skills. So make sure you go and check it out on the link provided and get your multimeters while they're still available.